The actual conductor is a silica glass or plastic core. This core is surrounded by a refractive coating called cladding, which provides a reflective surface and causes the light to travel along the entire length of the core. The third layer is a buffer coating to protect against moisture and other damage. It also prevents light from escaping the strand and may have a color coating for identification purposes. Fiber optic strands are loose buffer cables. The fiber strands are contained within buffer tubes, allowing the strands to move freely while also providing additional protection for the strands. The addition of buffer tubes and other protective layers causes the cable diameter to fiber cable that is used outdoors is normally filled with a waterproof gel. The buffer tubes may also contain this gel, as well as a water-blocking coating between the inner and outer jackets. Both inner and outer jackets are made of materials designed to resist corrosion and add greater protection to the cable. Some cables also have a metallic armored coating for strength and to protect against rodents. Fiber specifications list the core and cladding diameters as a ratio. Multi-mode fiber is usually either 62.5 by 125 microns or 50 by 125 microns. Single-mode fiber is commonly 9 by 125 microns.
Two additional characteristics of single-mode fiber that are important are cutoff wavelength and mode field diameter. Cutoff wavelength is the wavelength above which a fiber will support only a single mode. Wavelengths below the cutoff support two or more modes. The cutoff wavelength is determined by the fiber's refractive index profile, the length and bend of the fiber, as well as the cabling process and deployment conditions encountered during use. In a single-mode fiber, some of the optical power is actually guided outside the core. In fact, as much as 30% of the light propagates in the cladding layer of some fibers. The mode field diameter defines the size of the optical power distribution in the fiber. Multi-mode fiber has two important characteristics: numerical aperture and core size. Numerical aperture is the measure of the angular range of acceptance of light into a fiber. The angle over which a fiber accepts light depends on the refractive indices of the core and cladding glass.
It sends information coded in a beam of light down a glass or plastic pipe. It was originally developed for endoscopes in the 1950s to help doctors see inside the human body without having to cut it open first. In the 1960s, engineers found a way of using the same technology to transmit telephone calls at the speed of light. Normally that's 186,000 miles or 300,000 kilometers per second in a vacuum, but slows to about 2/3 this.
And the interface circuit process, making it compatible. In turn, varies the current to modulate. Finally, the optical energy into light. Light are sent through the transparent. The receiver consists of an amplifier and the photodetector to electrical signals and must be capable of detecting pulses.